Hey guys, welcome back to Organic Chemistry. Now we're going to do the E1 reaction. Okay, so at this point, you've done a lot of practice with E2. I know probably a lot more than you expected to, right? But it's long problems, but you learned a lot from it. Now, E1 is easy, okay? It's just like SM1. It's a very simple concept. So the good news, you're over the hard part. E2 was the hard part. It required the most practice. All right, let's get started with E1. The first thing we're going to do is talk about the kinetics of the reaction. So with kinetics, the rate is only dependent, of course, the rate constant, but on the substrate. So this is just like SN1, where it does not have any dependency on the base or the nucleophile. So this means, of course, like we know, if you double the rate of the substrate, you double the reaction. But if you do anything to the base, it doesn't do anything to the rate of the reaction. Okay, this is a unimolecular transition state, right? So we know that there's one molecule and only one molecule involved with the transition state. SN2, E2, two molecules involved. SM1, E1, one molecule, the substrate. That's it. Okay. Now, as far as the mechanism goes, well, let's say we have a carbon, and actually I'll do, because we've done the E in good detail now. So let's put a BR like that, and let's consider what happens. Well, first off, we have the same things. We have alpha, we have beta, and we have beta, okay? Just like we did with E2. However, it's not going to happen at the same time. So if I have a base, I'll write A minus. What's going to happen first is we're going to wait patiently and get that BR to leave, right? So BR is going to leave. We're going to have a carbocation form, just like we did with SM1. Carbocation forms. Now the base comes in. And now, because the base right now is coming in after the rate determining step, we always go with the Zaitsev product. So when you pull off an H, we're going to pull it from the beta carbon. Here's alpha, here's beta, and here's beta. We always pull it from the carbon that has less H's, and a double bond forms. So this is the major product, this is the minor product. Out of those two. Now, can you get some of the other? Can this happen? Sure, you can get alpha beta this way. This is the minor product, and this is a minor product, meaning it doesn't happen often at all. This is the major product. So with E1, we always favor Zaitsev, okay? That's the cool thing. It's simple. You make the halogen leave, and you make an alkene from one of the beta neighbors, and you always look for the most stable alkene. That's it. Okay, so this is the energy, this is the reaction. Here's the energy diagram. So just like SN2 and E2 have the same diagram, SM1 and E1 have the same. You go over transition, higher in energy, you drop, lower in energy. Here's reactant, here's product, and there's a transition, intermediate, transition state 1, transition state 2. So it's just the same diagram as in SM1. Okay, so there's not much to say. Again, just remember that you're making a carbocation, and so we're going to think about things related to that. How do you stabilize the carbocation? That's what we're going to discuss. But E2, because everything happened at the same time, we had so many things to keep concerned with. We had to worry about periplanar, the anti-periplanar. We had to worry about the strength of the base. We had to worry about, all these different factors, the solution. In this case, not much to worry at all, okay? And you'll see that right now. So let's go through the details. So here are the factors. Let's do the same order. So let's go alkyl group. So for the alkyl group, we want to make a carbocation. And so we want to make sure we get the most stable carbocation, higher degree. So remember, carbocation stability is like this. The higher the degree, tertiary is the best, secondaries follow, primary, and then methyl. This is our stability. Never vinyl. Never vinyl. Okay? Never double bond carbon. Never make that carbon positive. So it turns out that this is cation stability, and because tertiary is so good, it's the best, secondary follows. Never primary, never methyl, and never vinyl. So for E1, it's simple. It's the same trend as SM1. Tertiary and secondary only. That's it. All right. Now we're going to add allyl into this, but not now. Allyl is the carbon next to the double bond. I didn't add it in intentionally, not at this point, because when I go through different passes when you learn this material, and so there's a lot of things we're going to add into this as we go. But for the first round of learning, this is what I want you to think about. This right here. Okay. So never primary, never methyl, never vinyl. Period. And it's because of carbocation stability. Remember, we talked about the two aspects of carbocation stability: hyperconjugation and inductivity. It's the same thing, no different here. Same reason. Okay. For B, let's talk about the leaving group. And you'll be happy to know, which you probably know already from the card I gave you, it's the same thing. It's going to be OTAS or OMS or OTF is the best. And then I, BR, CL, F. So same exact trend, same reasons, same stuff, right? It's more stable. The weaker the base, the better the leaving group. All that stuff applies here as well. No need to talk about it again 4 times. C, let's talk about the solvent. For the solvent, it turns out just like SM1, protic is favored. Now, why is protic favored? Because a protic solvent can stabilize the carbocation that's forming. So remember, we're making a carbocation. And so the protic solvent stabilizes a positive carbocation, and it helps push out the leaving group. Notice how it's the same exact thing with SM1. Same reasoning. No difference. Okay? You'll learn in the next video that SM1 and E1 go together always. Okay? There's one way to make an exception, but we'll talk about that then. But they have the same pattern, same philosophy. Okay? All right. Let's talk about D. Let's talk about the base. Remember SM1? It didn't matter. E1 doesn't matter. Weak base is usually the pattern. It doesn't matter what the base is because it has nothing to do with the rate determining step. The rate limiting step, the slow step of the reaction, is making that carbocation, right? So after that, it's all flowing very quickly. So any base. So usually neutral, H2O, ROH, NH3. Notice the pattern, RNH2. This is the same exact list that I gave you for SM1. It's the same as SN1. No different. They have the same thing. Neutral is best. Okay? Does it mean it won't work with negative? Of course it'll work, but it's not necessary. And if you have negative, you start pushing in the wrong direction, SN2E2. We'll learn about that soon. All right, so that's D. E. Let's talk about, well, we did everything, right? We did the alkyl group, we did the leaving group, we did the substrate, we did the, we got to do stereochem. Well, first off, let's do selectivity. So we'll keep that pattern going with E2. There is no, well, actually, I shouldn't say no selectivity. Zaitsev is favored all the time. Very important. So you don't have to worry like E2. You don't have to think about where's the best place to pull the H. You're always going to know. Forget about the base because it has no influence on the rate. It's all about the most stable position, the beta carbon that has less H's. So in the ring system, actually, yeah, you know what? Let me not do the ring because I want to get into stereochem and then the ring. So Zaitsev is always favored. If I have a thing of alkyl bromide like this and I use water and it's E1 favored, we'll talk more about that in the next video. Well, when this leaves and a carbocation forms, I know my major product is here. That's the major product. That's what's going to happen the most. Why? Because it's favored Zaitsev, right? This is alpha, this is beta and beta, and the beta carbon on the left has 2 H's, the beta carbon on the right has 3. We don't pull from the 3H position. Is it a possible product? Yes. The reason why I emphasize that is because sometimes they actually ask that on the exam. They say, what's all the products? So all the products would be every beta location, but the major product is what I'm showing you here. Always trans and Zaitsev location. Okay. Finally, the stereochem. F, stereochem.